afternoon, students. In the last lecture, when we had completed our DirectX topic, we had been remaining with some topics of this chapter. So today we'll be continuing with that chapter. So the topic after the DirectX components, the topic which is there is versions. So which are the versions that we'll be learning here? For each new version of DirectX, Microsoft updated the technology such that the new DLLs, data language libraries, can communicate with the hardware faster and more efficiently with the minimum latency. That is, with minimum number of time taken and speed, you can more efficiently work on the hardware to get a proper consistency in the communication. They are trying to support the latest features of graphics. Latest features of graphics are brought into consideration, and sound graphics, that is sound cards that come on the market. So sound cards and graphics are being more and more updated over the DirectX version so that they can be used in normal conditions. The architecture is updated so as to suit the needs of the day while maintaining backward compatibility. So maintain a hardware compatibility or hardware compatibility. For that reasons, a maintained updated architecture is being required. Then the versions are DirectX 1.0, which was released in late 1995, with DirectX 6 version, two independent SDKs, that is SDK stands for Software Development Kits, DirectX SDK and DirectX Media SDK. Two independent kits were being released for DirectX 6 version. Then DirectX 7 version was DirectShow. The significant part of Media SDK merged into DirectX API and DirectX Media deprecated. So all these things are under one SDK, that is Media SDK for version 7. Version 8, DirectDraw and Direct 3D merge into a single DirectX graphics API for graphics programming. Graphic programming was possible in version 8. Direct Sound and Direct Music merged together as DirectX Audio. So that was converted into DirectX Audio for sound programming. And programmable pixel shader and vertex shader introduced in version 8. Version 9, that was HLSL, that is high level shader language, a powerful new programming model that offers the easiest to use graphics creation tool set for developers to introduce. For developing game programming engine, the new tool sets were being introduced in the DirectX 9 version. Now DirectX 10 was a part of Windows Vista. So no backward compatibility except via a software layer. Much faster DLLs, data language libraries, were there. Then departure from driver model of Direct 9 X9 with the addition of a scheduler and memory virtualization system. Virtual memory was brought into consideration. DirectX 10 will forego the current DirectX practice of using capability bits to indicate which features are active on the current hardware. Instead, DirectX 10 will define a minimum standard of hardware capabilities which must be supported for display system to be DirectX compatible. So it has some different features, it has different hardware capabilities. These all things are there in DirectX 10 version. So which version of DirectX do various versions of Windows come with? So 95, 95B, NT, NTB, SP, 98, 98 SE, ME, 2000 and XP. These are the Windows versions which are compatible with DirectX, with different their own compatible versions for DirectX. So 95 runs with none, 95B runs with DirectX 3 version, then DirectX 2, DirectX 3, then 5, 6, 2000 runs with DirectX 7.1, XP runs with DirectX 8.1. The screenshots of DirectX game programming developed is like this. The pixel variations and pixel variety from games, from graphics to changing 3D modules, all such programs were there. Then DirectX in detail. So what is COM? COM objective, component object model. So DirectX is a set of APIs available as COM objects. So component object model. So DirectX is a API for object COM, that is component object model, is a Microsoft platform. It's a Microsoft platform for software componentry introduced by Microsoft in 1993. Microsoft introduced a componentry that is called as a platform, that is component object model, and it is used to enable cross applications communication and dynamic object creation in any programming language that supports the technology. So cross platforming is one game from one hardware from another. Likewise, cross programming to build up a function, all that will support the programming languages as well. Now only your front end is not the requirement, back end also is the requirement, and that is the reason we require both compatibilities over a cross platform. Cross platform is one OS can be different, another systems API can be different, so those cross platforms can be combined to develop one programming. Then all DirectX interfaces inherit from IUnknown and are COM compliant. COM compliant means they are compatible with component object model. Interfaces means which are visible for user screen. IUnknown are the functions which are under IUnknown are add reference, release and query interface. These are the functions which are used. And reference counting, COM allows Microsoft release an enhanced set of DirectX components that are completely compatible with earlier versions. Yes, updations are made on earlier versions only, so you get updated feature, and for that reason only you have DirectX. And reference, why it is made? To check whether it can be compatible over updations also. With COM's independence of a programming language, developers are free to choose whatever COM compliant languages and development environment they wish. So it is their wish, users which what component languages they want, and what developers want to are free to choose whatever languages they prefer with the help of COM compliance, which are compliant with COM, that is compatibility is good with COM. Then with COM's programming model, that is component object models programming model, the programmer is assured that even if the user upgrades or changes hardware configuration, the DirectX drivers, the software will work without reconfiguration. So they are made in such a way, they are developed in such a way that even if the user after using DirectX, if it upgrades its hardware configuration or makes changes in the hardware, but DirectX drivers will be the same as they are running, they do not require reconfiguration. Then this is the example of compatibility. Then this backward compatibility plays a significant role in DirectX position as a leading API. DirectX is a leading API, and as it helps the applications written in older versions to still work smoothly in the newer versions. So it has a benefit that it can run with the older versions and it can be compatible with the newer versions also. It does not change its pattern. So how it really works? DirectX provides the interface to access the advanced feature of the display adapter. So rather your display is in a updated version, it's in a new features, rather it will be able to help as an interface. It will provide an interface so that it can merge with the display adapter, which are not provided in the standard Windows GDI graphic interface. If you change the interface, Windows will not be able to provide you this, which DirectX provides. It accesses the hardware abstraction layer in Windows directly. DirectX has an abstraction to Windows directly. When DirectX was introduced, display adapter vendors were quick to develop DirectX drivers that would expose low level functions of their hardware to the application. So this was a competition which was being made, because not to implement such things but to expose low level functions, DirectX drivers were introduced, but that they were fail and they still are compatible with the Windows functions. Next is the architecture. Now when I talk about the architecture, so this is basically my architecture of the DirectX function. So how they are working, we had read about direct input, direct sound, um, direct draw, then I have direct 3D, direct setup, direct play, that is under DirectX. I have a Windows Win32 application which is running. Then I have GDI, that is graphical data interchange format. Then I have interface, again HEL, that is hardware emulation level, hardware abstraction layer, and the actual hardware of my whole system and Windows drivers. So this is the architecture which is running. So we'll read one by one. Each chip manufacturer, board producer or OEM implements a HAL, that is hardware. HAL stands for hardware abstraction layer, for which implements only one device dependent code and performs no emulation. Emulation means you cannot adapt it on another system. The HAL is implemented using 32-bit code. So HAL is developed under 32-bit code with Microsoft Windows XP, Windows NT and Windows 2000, Windows 98 and Windows Millennium Edition. For these are the Windows and a use of combination of 62-bit and 32-bit code. So HL is implemented for 32-bit code for Windows variations versions, as well as both combinations of 32-bit and 16-bit systems. HAL can be a part of display driver for a separate dynamic link library. Then that communicates with the display driver through a private interface that the driver's creator defines. So there is a DLL also separately. Then HAL is based around the hardware support and is very fast but might not support everything. It is faster in speed, but it will support everything or not is not confirmed. Then there are certain HEL functions, hardware acceleration, which uses your normal software in the system RAM, physical memory. So this is the architecture of your DirectX. And then there are 3D graphics, rendering means the process of generating an image from a model by means of software program. So from a 3D scene, creating a 2D image is called as a rendering process, that is converting a model into a program, that is converting an image into a model with the help of a software program is called rendering. So the application is your game and is where you do any scene management and any tessellation of mesh, etc. So you then feed the graphics card with vertices and other data. So these are the requirements what we do while rendering, that is feeding the data, then with a graphic card, then adding vertices and data. Then the graphic card processes the vertices by transforming and lighting them in the using matrices supplied by the application. So matrices on how many times it is going to be matrized, that is multiplied and run over a time of period for that particular vertices to transform into lights and lightning and transforming. The card then culls any invisible polygons, so with any invisible polygons and clips are to view report. This transformed data is then rasterized and passes through pixel operation. So pixel, each and every pixel is being counted and then the data is being displayed to the user. So this is where it performs the clipping, that is 3D graphics pipelining, how the data is converted into a proper graphic, that is vertex data and primitive data. Then tessellation, then fixed function pipelining and programmable pipelining, both are converted into clipping. And backface culling, attribute evaluation and rasterization. Rasterization will change into pixel. Pixel will give it a texture as well as a surface, that is all the sides and then the level, everything. Then alpha test, depth test, tensile test, fogging and alpha blending is done for image to get converted. So this is the process for graphic to be converted. From here we'll continue in the next topic. Thank you.